Hi guys, there was a particular kind of problem that we weren't able to get to in class the other day, and I wanted to go ahead and do a few examples of this. There's not really a good name for this, but you might call it complex factoring. It's more interesting factoring, or factoring where the expressions are a little bit more complicated than some of the other examples. So here's an example of such a problem. You have a homework problem that's similar to this, and you might see a problem like this on a quiz or an exam, so you want to be ready to do this. This kind of factoring problem shows up in calculus problems. It's actually very common in calculus problems, and so you want to be reasonably good at it if you are planning to move on to calculus. So let's take a look at this. Remember, when you're factoring, you're trying to identify common factors in each clump of multiplication. So in this particular example, there's two big clumps of multiplication. There's this clump of multiplication and this clump of multiplication, and they're separated by a plus sign. And for each clump, we want to identify the factors that they have in common. From a constant standpoint, we have 6 here, which is 2 times 3. And over here we have a couple copies of 2. So 2 looks like it's going to be a common factor that we can factor out of the expression. Right? This clump has a 2, and this clump has 2 2's. Now we can't pull both 2's out. We're only going to pull the 1 2 out. So we'll go ahead and get rid of this 6 here because we're done with it, and get rid of that 2 and one of these 2's. Both of these expressions have a 6x minus 5 factor. The first bundle has 2 of those, this exponent 2. I think of that as there being two copies of 6x plus 5 sitting there. This bundle has 3 copies. Now we don't want to pull away more than we have, so we're going to pull away 2 of them. 6x plus 5 squared. So we got rid of all of these 6x plus 5's, and we got rid of all but one of these 6x plus 5's. Both of these clumps share a common factor of x squared minus 4. This version has 2. This bundle only has 1, so I can pull 1 away. And if I pull away 1x squared plus 4, I'm left with 1 here, and I've gotten rid of all of them there. All right, so after I pulled out my common factors, what I have left is 3 times 3, which is 9, times x squared plus 4 from the first bundle. From the second bundle, I have a 6x plus 5 left, as well as a 2x. All right, so there's our factoring portion for this. Again, we identified the common factors and then pulled them out. Actually, these two expressions are equal. And then we can do some simplification inside the brackets. So I'm just going to copy down all of this junk up front, the stuff that we factored out. X squared plus 4, we might be interested in factoring that, but x squared plus 4 does not factor. It's a prime polynomial over the integers. We'll be able to factor it once we talk about complex numbers. Inside the brackets, we can go ahead and distribute some things. So we can do 9x squared plus 36. I distributed the 9 through the parentheses. I can also distribute the 2x through over here. It's nice that we don't have any minus signs here, so we don't have to worry about any sign errors. 6x times 2x is 12x squared. 5x times 2x is 10x. And once we're all done with that, we can combine like terms on the inside as well. 6x plus 5 squared, yada, yada, yada. I can combine my 9x squared and my 12x. That gives me a 21x squared. I only have one x term, 10x. And we have a 36 as well. All right, now we might be interested to see if this polynomial factors as well. Let's use the AC method. I have A is 21 and C is 36. So A times C is 21 times 36. Let me get my calculator. I wasn't planning on needing my calculator. Let me find it real quick. Here we go. 21 times 36 gives 756. Let's see how we can factor 70. Now, I guess the AC method, we're looking for factors of 756 that combine to make 10. Okay? Since my constant expression here is positive, both those factors are going to have the same sign. And since my middle coefficient here, 10, is also positive, both of those signs are going to be positive. All right, so 756 factors into 1 times 756. That adds up to 757. That doesn't work. 756 also factors into 2 times 378. 2 plus 378 adds up to 380. That's not 10. We wanted this to be 10. Let's see. 378. Is this thing divisible by... Yeah, this is actually divisible by 3. Times 2 divided by 3. Oops. If I take 756 and divide it by 3, I get 252. So this is 3 times 252. When I do 3 plus 252, I get 255, which is not 10. So we got to keep going here. I'm going to run out of space. It's also divisible by 4. When I take 756 divided by 4, I get 189. 4 plus 189 is 193, which is not 10. So we got to keep going. 756 is also divisible by 6. When you take 756 divided by 6, you get 126. Six plus 126 gives you 132, which is not 10. I think the next smallest factor is maybe 12. 5 is definitely, it's not divisible by 5, definitely. Is it divisible by 7? 756 divided by 7. It is. 756 divided by 7 is 108. Actually, I'm silly. I could just look at 21 and 36 and realize what some of the factors are. 7 plus 108 is 115, which is not 10. Is it divisible by 8? It is not divisible by 8. It is divisible by 9. $756 divided by 9 is 84. 9 plus 84. Whatever it is, it's not 10. All right, now we could keep going here and check all the possible ways that this factors, but we're adding our factors together, and we're trying to get something that's 10, and so I guess both of my factors have to be smaller than 10, and I think it should be obvious that I can't find a pair of factors here where they're both smaller than 10. So, anyways, this guy is not going to factor anymore, so we're done factoring with this expression. So we've gone ahead and simplified it. So all right, so it looks like we wasted the last 5 minutes trying to factor this quadratic without being able to. We might have a faster way to check to see whether a quadratic is prime later on. All right, so that does it for this example. Again, you have a homework example that's very similar to this. An example that involves a fractional expression here. So now there's actually kind of three bundles of multiplication. I've got two terms on top that are separated by a minus sign, as well as a term on the bottom. We're going to focus on the top first. All right, so the expressions on the top, they share, let's see, from a constant perspective, the first bundle has a 3. The second bundle has a 2 and a 4, 4 factors into 2 times 2. So they don't share any common constant factors. Variable expression-wise, I have an x factor here and an x factor here. The x factor in the first term on top shows up twice in the first expression and 3 times in the second expression, so I'll pull out 2 of them. That leaves none here and only 1 here. And both terms on top also have an x minus 5 factor. It occurs 4 times in the first expression and 3 times in the second expression, so we'll pull out 3 of them. X squared minus 5 cubed. And then what we're left with after factoring, those are the only common factors in the numerator. What we're left with is 3. Actually, sorry, let's see, when we factor out 3 of these on top, there's none left here, and there is only 1 left there. All right, so what we're left with in the first bunch is 3 times x squared minus 5. From the second bunch, we have an x, as well as a 4, as well as a 2x. And we haven't done much with the bottom. I'm actually going to go ahead and preemptively, we're going to end up doing some canceling too. I'm going to preemptively split off 3 of these x squared minus 5s in the bottom. So x squared minus 5 to the 8, I can split that apart as x squared minus 5 cubed times x squared minus 5 to the 5th, using some properties of exponents. Again, these two expressions are equal, and it's maybe a good idea to indicate that. All right, we can go ahead on top. Actually, we can get a lot done here. I guess I have 3 terms on top right now. X squared minus 5 cubed, and this bundle of nastiness that we're going to end up simplifying. So you can write the top as a multiple of 3 factors, and the bottom as the multiple of 2 factors, and the top and the bottom share a common factor that I can cancel. I can cancel x squared minus 5 cubed and x squared minus 5 cubed. So there's some good cancellation there. So all right, we got an x squared left on top. Inside the parentheses, I can distribute. I can have a 3x squared minus 5. Oops, not minus 5. I need to distribute the 3 onto the x squared and the 3 onto the 5. That was almost some bad news. So 3x squared minus 15. When I multiply these 3 terms, it ends up being, well, I'll go ahead and take this, well, let's do this off on the side. X times 4 is 4x. So I got 4x times 2x, which is 8x squared. All right, then on bottom, I'm left with x squared minus 5 to the 5th. I can combine like terms inside the parentheses. I have x squared times 3x squared minus 8x squared is negative 5x squared minus 15. And then inside the parentheses, I have a common factor of negative 5. I can write negative 15 as negative 5 times 3. So I can factor out a negative 5. Negative 5 x squared times x squared plus 3 all over x squared minus 5. I messed up an exponent along the way. This should be to the 5th here, right? Let's make that a nicer looking 5. I copied things down wrong. Those transcription errors will kill you. And that's about the best we can do. I would probably personally write this as put the minus sign all out front. I like to get my minus signs out front whenever I can. And so this would be my final answer, but you could definitely stop at the previous step if you were comfortable with the beauty of this expression. Okay, so that one was a little bit more challenging because we had some numerators and denominators, but still same ideas. This last one is actually very challenging. Those of you who aren't taking calculus, you can feel free to go ahead and stop the video now. This is not going to be something that we want to worry about so much in Math 136 unless you want to challenge yourself. But this is exactly the kind of expression that will show up in a calculus class. And so those of you who are moving on will maybe want to be able to do some of this. All right, so first things first, I have two terms. Separated by a plus sign. The first term, as far as constant factors go, the first term has a fraction as one of its constant factors. And I don't like fractions at all, so I'm always going to factor out fractions. So we're going to factor out this 1/3. Even though the second expression doesn't have a 1/3 factor, we're going to go ahead and factor out actually a negative 1/3. Now, I think I mentioned this in class. I got 3 classes, so I can't remember what I mentioned in what classes. But factoring out is similar to dividing each term by a constant. All right, so when I factor out the negative 1/3 here, I think it's clear that it's just going to cancel out. When I factor out negative 1/3 over here, we're dividing by, like I said, we're essentially dividing by negative 1/3, which is the same as multiplying by negative 3. Remember, division is the same as multiplication by the reciprocal. Okay, so factoring out the negative 1/3 here and over here it has the effect of multiplying this expression, like introducing a new factor of negative 1/3. And that's a little bit confusing the first time you see it. That's kind of why I'm doing this particular example. All right. Another common factor that these two expressions share is an x minus 6. Now the exponent on the first version is negative 4/3, and the exponent on the second version is negative 1/3. We always factor out the smaller exponent, which is negative 4/3 in this case. Negative 4/3 is less than negative 1/3. Okay, so we're going to factor out x plus 6 to the negative 4/3, which makes these go away. Now, remembering that factoring out is similar to division. When I factor out the x plus 6 to the negative 4/3 from the second expression, I'm effectively taking x plus 6 to the negative 1/3 divided by x plus 6 to the negative 4/3, which is the same as x plus 6 to the negative 1/3 times x plus 6 to the 4/3. That's some properties of exponents. More properties of exponents would say that this is x plus 6 to the negative 1/3 plus 4/3. And 1/3 plus 4/3 Sorry, negative 1/3 plus 4/3 is just 1. Okay, so when I factor out x plus 6 to the negative 4/3 from this version, I'm left with an exponent of 1. Okay, so there's going to be an x plus 6 to the 1 left over there. All right, the last common factor that these two expressions share is x squared plus 9. This one's a little bit easier. I got 4 here and 3 here, so I'll factor out 3 of those. X squared plus 9 cubed. And then what we're left with, after factoring everything out, oops, I forgot to do, when I factor out x plus 9, x squared plus 9 cubed, I'm left with none there, and I'm left with 1 here. So we're left with an x squared plus 9 from the first term. We're left with x plus 6 times 4 times 2x times negative 3 from the second bundle. And now we just have some simplification to do. I'm not going to do anything super fancy out front yet, other than write x plus 6 to the negative 4/3 as 1 over x plus 6 to the 4/3. Inside the parentheses here where we have most of our simplification, I'm going to focus on the second bunch first. I'm going to actually combine these 3 terms first. So we got x plus 6. 4 times 2x is 8x times negative 3 is negative 24x. I'm going to start to lump some of this together in one big fraction now. I'm going to have negative out front and x squared plus 9 cubed on top, and a 3 times x plus 6 to the 4/3 on bottom. Inside these parentheses, I still have x squared plus 9. When I distribute the negative 24x onto both pieces, I have a negative 24x squared and a negative, let's see, what's 6 times 24? 6 times 24 is 144 minus 144x. All right. I'm not going to copy this junk down. Let's just say copy it down. Still simplifying inside the parentheses. Negative 23x squared minus 144x plus 9. And then I'm going to go ahead and factor out a minus sign here from this. I'm going to factor out a minus sign. It's going to cancel with the minus sign that's sitting out front here. And then I'm just left with x squared plus 9 cubed all over 3 times x plus 6 to the 4/3 times. When I factor out this minus sign, it just has the effect of changing all the signs. So 23x squared plus 144x minus 9. And then I'll finish off by writing this as one big fractional expression. X squared plus 9 cubed times 23x squared plus 144x minus 9 all over 3 times x plus 6 to the 4/3. And now, see, I'm a little bit worried as to whether or not this 23x squared plus 144x minus 9, whether or not that cancels. So, all right, let's just do this. Our AC is 23 times 9. Sorry, 23 times negative 9, which is 23 times negative 3 times 3. That's how I'll factor it. Let's see. As a whole number, what does this end up being? Sorry, That's just a single number. 23 times 9 is 207. Negative 207. All right, so when I pick my factors, since the constant term is negative, one of my terms is going to be negative and one of them is going to be positive. They're going to have opposite signs. And since my middle coefficient is positive, the larger number is going to be the positive number. The larger factor is going to be the positive factor. So I could factor negative 207 into negative 1 times 207. If I do negative 1 plus 207, that gives me 206, which is not 144. I could also factor this into negative 3 times, what's 23 times 3? 23 times 3 is 69. And if I do negative 3 plus 69, I get 66, which is not 144. I could factor this into negative 9 times 23. Negative 9 plus 23 is equal to 14, which is not 144. And I think that's the only ways that we can factor negative 207 such that the smaller factor is negative. So we're not going to be able to factor the 23x squared plus 144 minus 9. And like I said earlier, we're going to have a faster way of checking to see that that doesn't factor nicely here in just a few weeks. And so that's going to be my final answer as to how this expression here, or sorry, the one that we started with, how this, wow, we've got to go way back up. Yeah, that's how that simplifies. Like I said, those of you who aren't going to move on to calculus, you'll never, ever have to do anything that complicated. So if you decided to stick with me on that one and that one kind of confused you, don't worry too much about that one. But even those of you who are moving on to calculus, don't worry about it so much for this class, but know that you'll probably have to do something like that in your calculus class. All right, those are the only examples that I had prepared here. If you have any questions about these kinds of problems, please ask. Either use your Ask Your Teacher feature in WebAssign, or send me a message on Ivy Learn, or ask me during the next class. That's all for now.